This is matrix matching type of objective where in one column different pairs of compounds are given and we need to find out what are the various types of isomerism exhibited by these pairs of compounds. Let's see one by one. The first one, let me extend this one and write in terms of the carbon hydrogen framework. It is like this: CH3, then CH2, then one more CH2. Then the aldehyde group can be written exactly like this: C double bond O and hydrogen. Now remember, when you are talking about isomerism and whenever there is a carbonyl group, immediately you need to check out whether there is any alpha hydrogen or not. And here there is alpha carbon and these are the two alpha hydrogens. So once there is a carbonyl group attached to alpha carbon with hydrogens with minimum one hydrogen, definitely we can say that this particular compound exhibit keto-enol tautomerism, isn't it? Because the alpha hydrogen can migrate from this particular position to the third position to the oxygen here, and we get this structure CH3, CH2. As the hydrogen is migrated, there is only one hydrogen. Now here it becomes a double bond and this becomes a single bond along with OH group. So this is a keto form and this is the enol form. So this is an example of keto-enol tautomerism. So definitely one of the matching is tautomerism. And there is no chance of any ring chain isomerism because there is no ring at all. Now let's check out whether there is any chance of functional isomerism or not. Definitely yes, because here the functional group is aldehyde and here it is the OH group along with a double bond. So both are having the same molecular formula but differ in the functional group. So they come under functional isomers. So definitely in our matching even functional isomerism should be there. And there cannot be any chance of metamerism. Why? Metamers means these are the isomers which are having the same polyvalent functional group attached to different alkyl group. So for A, the correct match is both Q as well as R. Let's move to the next one. It is like this. Again, we can clearly see the keto group here, here as well as here, and all these becomes the corresponding alpha positions. So on this alpha atom there is a hydrogen. So definitely here there is a carbonyl group attached to a nitrogen containing alpha hydrogen. So definitely there is a chance of tautomerism, isn't it? This nitrogen can be migrated here so that this becomes single bond OH and we get a double bond here. Then again this hydrogen can be migrated to this particular oxygen to get a OH and this becomes a double bond. This is one double bond, this is another double bond, and same with the case of this one also. So this alternate double bond and single bond is represented by this ring which is nothing but the delocalization. So definitely these are a pair of tautomers because they comes under the example of keto-enol tautomerism. As both are ring compounds, no chance of ring chain isomerism. Again, in both of them, the functional groups are different, same as that of the previous one. So that comes under functional group isomerism and no chance for metamerism. So for B, the correct match is both Q as well as R. Then for C, it's very clear from the structure that both are tertiary amines, isn't it? Because the functional group is nitrogen, where in both the cases the alkyl group attached to the nitrogen are different. If I take R1, R2 and R3, it is methyl, ethyl and ethyl. And in this case, R1 is methyl, R2 is also methyl and R3 is propyl. So these are metamers because both are having the same polyvalent functional group attached to different R groups. And there is no chance of tautomerism. The functional group is the same, so no functional group isomerism and no ring chain isomerism. So for C there is only one correct match, that is metamerism. The last one is this CH3 CH double bond CH2 which is an alkene. The second one given is cyclopropane. So this is an open chain compound and this is a ring compound. So this comes under the ring chain isomerism. So there is no separate functional groups and no tautomerism and no metamerism. So for D, the correct match is only P. So what's our answer now? For A, the correct match is Q and R. For B, it is again Q and R. For C, it is S. For D, it is P.